Well, thanks for having me, guys. I'm Shawn Stover, the territory rep for Sporland. I was here last, I don't know if it was quite a year ago, where I showed you guys Zoomlock Max, Zoomlock Push, the Brazos refrigerant fittings.
Yeah.
So Tom asked me to come back again. I appreciate it, and so I'm going to cover basically more or less like our A2L updates on what we have on components and still some best practices and everything. But if you got any questions throughout the training, feel free to just, it's very conversational. So if you guys have a question, just go ahead and shoot them out. Here's my contact information if you guys ever need to get a hold of me, anything Sporland related. So I live in Worcester, just down the road from y'all, but I cover Ohio, Western PA, well, the lion's share of Pennsylvania, like Scranton, Wilkes-Barre, State College, Altoona West. I go up to Rochester, New York, and then all of West Virginia as well.
Oh, shit.
Yeah, I'm on the road quite a bit, but trainings like this that are less than an hour away, I enjoy.
Yeah.
So I can sleep in my own bed tonight. But here's my contact information, email, cell phone, if you do need to get a hold of me. I do have my card as well, so if you just want my business card, I can get one to you. But been with Sporland about 5 years now. I was with a different division of Parker Hannifin for a few years prior to coming over to the refrigeration side. But it's been a drinking from a fire hose, but hopefully I can help you out. Going to talk about A2L. I'm sure you guys have been over inundated with A2L information. If at any point I'm standing in your way, just
You're good.
tell me to move. I'm sure you guys are loving all of the transitions coming in the industry, and you're getting information overload probably for every component that you're seeing. So I'm happy to contribute to that. This will be my spiel as well. Hopefully with this, you guys aren't on information overload too much, but I hope to basically cover these questions for you. So gonna look at the new A2L refrigerants, how they affect our expansion valves, what changes we had to do, how we use them for both R32, R454B. We'll talk about the catch-all and any changes or requirements for that. For the new A2L refrigerants, looking at our solenoid valves, just a quick note on here. Our HP solenoid valves, essentially HP stands for higher pressure. We had to create those for like the pressures of like 410A. With the new UL requirements, we only listed the HP valves with the UL listing. So any A2L systems, you're gonna have to use the HP version of that valve. Looking at some refrigeration requirements on systems and what types of refrigerants to use for what system with the GWP requirements. I'll talk about our BQ valve, how you can potentially build an A2L TEV with our BQ bench. Leak detection, UL requires the use of safety shutoff devices to prevent any leak detection. Because it's a mildly flammable refrigerant, there's just additional requirements, so I'll talk a little bit about that. Have a little bit on R290 propane. We have an expansion valve available for that and aftermarket. And then I'll touch a little bit on CO2, not too much, but so a lot of exciting things that Sporland's working on as we transition to the natural refrigerants. So just a couple regulation dates to point out. We're already starting to see basically the 1st of January 2026, we're gonna have to go to A2L refrigerants for HVAC, right? We're switching to R32, 454B, 410A. Systems will no longer be able to be sold. One thing to note on here though, on the refrigeration side, I was mentioning there is GWP requirements based on systems. So basically, for retail food refrigeration and remote condensing units, well, not so much remote condensing units, but retail food refrigeration, if you have a system that's got a 200 pounds or greater charge, then there is a GWP limit of 150 GWP, right? But if it's under 200-pound charge, then they raise that up a little to 300 GWP limit. Those go into effect the 1st of next year. So you'll see a lot of small independent stores, restaurants, things of that nature, where you're going to be running into this depending on the size. So just keep those of note. I'll talk a little bit more about those and the specific refrigerants that are available. So looking at the TEV specifically for the A2L, first of all, a 410A system is an A1 system. It's a non-flammable. 410A is a blend of R32, which is a mildly flammable refrigerant, and a flame retardant to bring it down to A1 non-flammable. We cannot do a system conversion from an A1 system to A2L. It's got to be a whole new system. So there won't be any replacements, if you will. Our 410A uses our ZGA charge. Z is the refrigerant code for our 410A. R32, we're going to be using that same power head, the 410A valve. What we're going to be doing is we're going to start dual labeling these valves. So like an ERZE 5GA, 5-ton 410A valve, on the box we'll label it and we'll say 8-ton R32. So it's still using the same power head, but because there's no flame retardant, it dramatically increases the capacity of that valve. So we will have dual labeling on that, but rely on your wholesale partners or reach out to me if you have any sizing issues or questions, and I can help size that valve for you. We will need system conditions to properly size it though, just to let you know. So R454B is also a R32 blend. However, is it right here showing you? It's about 68.9% R32, but then it's over 30% R1234YF. That also makes it a A2L. However, because of the blend, the pressure temperature characteristics are far enough to where we had to create a YCP charge. So it would be like an ERYE valve to basically, we'd have to have that charge specifically so that we could properly mimic the pressure temperature characteristics of that refrigerant. So I have run into, I'm looking into, I know I was at RSC earlier today and they were saying carriers recommending a 410A valve replacement for a 454B system. I don't know what they're talking about on that, so I have to dig into that a little bit. But just know for 454B, we had created a specific charge for that refrigerant. So more information on that once I'm able to go on a little bit of a fact-finding mission. So looking at some capacity comparisons, as I was mentioned, like our ER valve, you're showing an 11% capacity going from 410A to 454B, and then a 37% capacity for R32. So that's why we're able to use the same charge, but you're going to see much more tonnage on that. Our HX valves, you're going to have very similar capacity swings. So you're still going to have to size for that specific refrigerant. A 5-ton 410A valve with a different power head for the YCP is not going to necessarily equivalent or be a 5-ton 454B valve. So I know this is a lot of information. I'm basically saying use wholesale, use me to size it, or on our website we have Virtual Engineer. It's a selector tool that you can actually plug. It'll highlight the necessary variables that we need for you to properly size that valve. It's called Virtual Engineer. So I think towards the end of this training I got a couple slides showing where it's at. All right, our BQ valves, you guys all had experience building a valve on our BQ bench before. So since 410A and R32 are using the same power head, you can actually build an R32 valve on our bench. As you can see, because of the capacity the dramatic capacity increases, you can build a 9-ton valve, an R32 9-ton valve on our BQ bench. So you have a pretty big range that you're able to do, but just showing you here, like an ER valve, a 15-ton ER valve for 410A, you're showing 15 tons, but you're almost at 21 tons for R32. So there is a significant swing. It's not going to be like for like. With our BQ bench, just know it's a pretty simple construction. You're just going to select the configuration, the body configuration, what you want. This particular one, it's an externally equalized valve. It's got the removable inlet strainer. You're going to choose the cartridge based off of the capacity, the system, and then the power head, the element, based off of the application and the refrigerant type. So on our BQ benches, we have a counter mat that basically shows you step by step how to build it. The O-rings, the rubber HMBR O-rings on the cartridge, you just put a little bit of oil on that. You put a little bit of oil on the threads of the power head. You pop that cartridge in and you screw it in until it bottoms out. And then that element, you put it on hand tight, and then you want to do one wrench flat. So I think it's like 60-degree additional turn with the wrench. And it's a good valve to use. Pretty simple construction. We actually have a BQ, like a Pelican case, BQ travel case. A lot of supermarket guys will use in the field. If they got a plug valve or a bad element, they can isolate that valve in a case, pop out that cartridge, put a new cartridge in, not have to pull out that entire valve body. So it makes life pretty simple.
Yeah.
Plus, supermarket guys, anytime they run into a bad valve, they don't want to necessarily have to make a trip up to United or whatever. They can just fix it on the spot. So it's nice. So as I mentioned, so our 410A, we have our ZGA charge, right? Our 32 is going to use the same charge. 454B has the YCP charge. And again, I'm showing over here the BQ valve. You can go fraction of a ton up to about 9 tons with the BQ valve. So currently, valves that are at wholesale, we have just somewhat recently started dual labeling these boxes. But in the meantime, what we're doing is we're going around to our wholesalers. We're just tacking on this sticker. It's basically showing you what ton change. So basically, this is a 410A valve, but it's going to show you 410A 3-ton valve is actually going to be a 5-ton R32. Try and make it pretty simple, self-explanatory for you guys when you're picking one up off the shelf. But over time, what we're going to do is you're going to see right here the 410A valve, but in parentheses right here. So this one's a ERZE5 GA. Over next to it, we're just going to say 8-ton R32. So should be pretty self-explanatory. Sorry if I feel like I'm being redundant here. It's just the fact that we want to make sure you're using the right valve for the right application for the right size. So R454B, again, the refrigerant code is Y. All of the R32 valves, we're going to be using a teal sticker. Teal is going to be the color designation for it. Whereas the 454 and 455 series are all going to be a gray sticker and gray jugs, right? So as you can see, we have a whole list of 454B valves that we're going to be that are already available for wholesale. The large tonnage, we got 55 and 70 ton. We're not making them yet just because they're not really out in the market just yet. So, and again, one thing to note, and I think it's in a later slide, for the 454B, we have a KT47, the power head. It's a KT47 YCP power head that we will be stocking on the BQ bench, that's designated specifically for 454B. Again, use virtual engineer, it'll help size the valves for you. Here showing a little bit of the capacity for 454. So basically, factory valves, let me take a look here. So it's basically showing you what cartridge for basically, for example, right here, from a 9,000 to 12,000 BTU, we're using for 454 an ERYE 1.5 ton CP. If you're going to build that valve, if it's 9,000 to 12,000 BTU, we're going to use a AA cartridge. But if it's larger than that, we're going to use a single A cartridge. If you have one that you need require to bleed, it's going to increase that capacity a little bit. So just know, again, I'm not going to get too into the weeds on how to build these valves for you. Wholesale will help you with that process. So just a little bit of refresher for you. The principal construction of a thermostatic expansion valve. So you got the charge that's housed in the bulb attached to the diaphragm by means of a cap tube. So the charge is either a gas liquid mixture, or a liquid. It's not just the refrigerant that's in the system. So like an R22 power head doesn't mean it's just R22 in that bulb. It's actually going to be a proprietary blend that will be very responsive to the pressure temperature changes of your suction line, right? So as this bulb senses a temperature change, an increase in temperature, it's going to put pressure down on the diaphragm, pushing on your push rods and pushing that pin off of the port, right? Allowing refrigerant to flow. This valve has got a closing spring, and then there's an adjustment assembly allowing you to either add additional spring pressure or pull it off. This valve is not showing it, but there's also evaporator pressure sourced if it's internally equalized, basically through a hole just drilled in the body, or from an equalizer line that you would source from the suction line. So basically traditionally you have three forces acting on the valve, right? You got your bulb pressure opening force, you got your evaporator pressure acting as a closing force, and then you have your spring pressure acting as a closing force. So those two closing forces are trying to keep that valve closed, but then when that bulb senses a temperature change, it's going to push down on those to try and feed that valve, get more refrigerant into your evaporator. Well, during certain points of the year, we dealt with what's called valve inlet pressure, and essentially you think about it, you almost think of like if you're making a whirlpool in a swimming pool and you got that current that's really ramming, and you try and walk against it, well, that current's still trying to push you. Well, that valve inlet pressure, when you got a ton of refrigerant cycling through the system, right, it's going to try and drive that pin open to feed more refrigerant through the expansion valve. But your application, your bulb is sensing the right superheat that it's dialed in at, so it doesn't want to open up that much more. But that valve inlet pressure is driving it open. So depending on the time of year, that valve inlet pressure can be a problem, and it can kind of counteract against properly feeding TEV. So what Sporlan did was we came up with a balance port expansion valve, and as you see, it's actually a push rod and pin assembly. It's all one milled piece, right? So you have basically right here, when this valve is closed, the surface area right here is going to be the same as the surface area, what they call the push rod shoulder. So you mill it down. So that surface area right there and this is going to be the same. So as you have that valve inlet pressure coming in, pushing down on the head, it's also pushing up on that push rod shoulder, effectively balancing that valve inlet pressure out. So it gives you a wider range of controllability. We say a conventional port TEV, so the like this one that has the push rods, conventional port TEV, you control down to about 35% capacity. A balanced port TEV, you can get down to about 25%. So it's just a wider range of controllability. I think Sporlan ideally would love to go to nothing but a balanced port design, but there's still a lot of guys in the field just want to change like for like. They don't want to, like, this is what the system had, this is what I want to buy, and there's still just enough of a demand that they still make the conventional port style. All A2L systems will be balanced ports though, just for your reference. So it's showing here, this is a bit of a dated slide. Our flare body valves, we've obsoleted. We don't make flare body valves anymore unless if you have to have a flare body, we do still have that option on the BQ bench. So you have to just build it on the bench. So, did you question? Are you good?
No.
Okay. All right, so here's just a little bit of an exercise showing you how superheat is calculated, right? So superheat is the temperature of a vapor above its saturation temperature, right? So on this system, you're showing on the suction line 52 degrees, and on the pressure, you're showing 68.5 degrees of pressure. So we're gonna take the actual temperature of the bulb and subtract the saturated temperature. I did not bring PT charts, they're probably in my car. But what you wanna do is you wanna convert that 68.5 to the saturation temperature, which is gonna be 40 degrees, right? So I won't, unless you got the app and you wanna pull it up just to double check my slides work. But basically you wanna subtract that saturated temperature from the actual temperature, and it's just gonna show you got 12 degrees of superheat. Does that make sense? I know for you guys it's probably elementary, but I just wanna make sure you're all good with that?
Yeah.
Does that make sense to you? There's a quiz on this. I'll hide these and we can do it over if you want. Basically what it's doing is superheat is the temperature above once it's saturated. So as you got liquid refrigerant coming through here, right, it's all boiling off. Once it boils, and while it's boiling off, it's at a constant temperature. So no matter how much heat you put on it, it's gonna boil off at that constant temperature. Once it goes to all vapor, then that temperature will rise. So just imagine here, your vac coil, say you boil off all the refrigerant right here. What's your superheat at that point?
Zero.
Yes.
Oh.
So 0, but then that temperature is going to increase to the point to the bulb, and that is your superheat above the 0 essentially. So sorry to pick on you. So oh yeah, right here. So follow the manufacturer's manual or instructions if it has something specific. If there isn't a specific setting, our general rule of thumb at Sporlan is air conditioning, heat pump applications, we range about 8 to 12 degrees of superheat. Medium temp is about 6 to 8, and low temp about 4 to 6 degrees of superheat. So that's just our benchmark that we use. I was talking earlier about adjusting an expansion valve, so you can, to change the superheat setting, you can add a little bit of spring pressure or take it off, depending on what you're trying to dial in. And just the ways to do that, right here's that TEV wrench I pass around to everybody. You wanna take that end cap off, and then there's a little packing gland that those teeth will fit in. You wanna loosen that packing gland, because that's gonna hold that valve stem in the position that you adjust it to, so that any kind of system vibration or anything's not gonna, make that move. Loosen that, then you wanna just turn the adjustment stem about a quarter of a turn, and then wait about 10-15 minutes to let the system settle out. Once you get the superheat setting that you want, tighten that packing gland back up, and then put that end cap on. That end cap has a knife edge joint. That's the final seal. If you don't put that on, you can leak refrigerant through that adjustment assembly. Don't over adjust one way or the other either, because you can damage that adjustment mechanism. But have no fear, we sell adjustment kits. So you just have to go buy a new kit, which it's okay. I happily will have one of my wholesalers sell you one.
Is it still 4 degrees a turn?
They say a quarter to half a turn. 4 degrees
Per turn?
I haven't actually seen that. I know different valve bodies have different amounts of turns, but if that's what you've seen,
That's old book stuff.
I was gonna say it very well could be. I haven't actually seen that as a benchmark, but I can look that up for you. I'll let you know. So, all right. So installing an expansion valve in a system, obviously, we want to use best practices. Wrap the valve up. Keep appropriate torch tip, keep the flame away from the body. You don't want to overheat the diaphragm. You can warp the diaphragm itself and it won't react properly to the bulb pressure. Also, on one of our balance port valves on the piston, or excuse me, the push rod, there's a small O-ring called a push rod seal that you can compromise that O-ring. If you melt that, you can leak refrigerant up through and out your equalizer line. And the one thing to know is, like, if you see your equalizer line starting to frost up, that seal's been compromised and you have to replace that valve, because eventually what will happen is that equalizer line will ice up and plug, and then you won't get that evaporator pressure. So so just keep the flame away from overheating. Also, you want to use nitrogen. If you don't use nitrogen, any flake or carbon buildup, once you charge the system, put oil through, it's going to act as a detergent. It's going to wash away that oil, and it's going to catch right on the pin of the expansion valve. They say that TEV is the best secondary filter in the system, because if catch-all's not going to catch it, the TEV will. So, all right, supply vapor, free liquid to the TEV inlet, right? You don't want to have any flashing, so where your TEV is doing it properly. You want to avoid any kind of pressure loss from flow friction, vertical lift, or any of our flow-through accessories like our catch-all solenoid valve or sight glass seal. And then your suction line, you want to make sure it's small enough where you're able to get that velocity to move that lubricating oil back to the compressor. That's going to protect your compressor, and then keep it large enough to where you're not going to be losing a big pressure drop. So, grab a sip here. The bulb location, you want to have it as close to the outlet of the evaporator as possible. Have it mounted on a horizontal free draining piece of the suction line. The closer you have it to the evaporator, the better sense it's going to have. So if it is sensing liquid, it's going to choke that TEV off, so that's making sure that it's not getting any liquid past. I think, yeah, on this next slide. You want to have good thermal contact. I've seen TEVs in the field where it'll have the bulb straps on, you think it's got a good contact, but then you grab it and then you can slide it around the suction line. That just means that it's not got a really good thermal contact, where there's actually a layer of air in between the bulb and the suction line, and you're not going to get as good of a reading. So make sure you have a good secure connection, and then you want to insulate that bulb as well so it's not getting a false reading from any ambient or surrounding temperatures. Mount it at the 4 or 8 o'clock position. Because why do you not want to mount it at the 6 o'clock position? Any
Oil.
Oil.
Exactly. If you got cold oil, it's going to sense that, but it's not going to sense the liquid refrigerant that's traveling over top of it. And you don't want to put it to 12 o'clock position, because then it's only going to be reading vapor, because you're not going to have a full column of liquid in that suction line. So 4 or 8 o'clock is going to give you the best reading. And again, use our bulb straps that come with the expansion valve to get a good secure connection. Don't use zip ties, don't use tape. Those things are just going to fatigue really quickly, and then you won't have a good secure connection. Make sure you are using a P-trap that's going to help pull any cold oil away from the bulb, and as that builds up, then you'll have the pressure be able to carry that refrigerant back to the compressor. It's going to help avoid getting a false reading with the bulb. So you got 4 basic scenarios on a TV, right? You got a TV that's not feeding enough, not supplying enough refrigerant to your evaporator coil. You got one that's feeding too much. Now you're sending liquid refrigerant back to the compressor. That's going to kill the life of the compressor, because you're going to wash away the lubricating oil, and you can't compress liquid. You are feeding not enough, then too much. So basically, you're hunting. So it's kind of the worst of both worlds. You're going to have high superheat, which is going to create high discharge temps or high compressor superheat, and then you're gonna be sending liquid back, so you're kinda hitting the compressor from both ends. Or if you got liquid flood back during startup, anytime you're sending liquid refrigerant to the compressor, you're taking life off of it, right? So your expansion valve, the primary purpose is to protect your compressor. So we want to make sure that it's feeding properly. So and I will, before I leave, I'll get PT charts for you guys. But basically, let me double check. I don't have any in here. No, they're in my car. On the bottom of the PT chart, on the back side, there are the next 2 or 3 graphs shows basically different potential causes for, like for this slide, low suction pressure, high superheat. It lists a bunch of possible causes. Basically, if you're running into low suction pressure, high superheat, before you adjust the superheat stem on your TEV, go through each one of these and make sure. Adjusting the stem on a TEV should really be the last thing you do in the system. Because if it was designed properly, if the system was designed properly, that TEV should not have to be dialed in. But if there was a refrigerant retrofit and a power head changed, then you might have to adjust it. But you don't have to worry about it. I'll get you a PT chart that has all these on here, so you don't have to worry about taking, I mean, feel free. But, so like for example here, low suction pressure, high superheat. Well, you could have contamination in the valve, and basically say you have a bunch of wax buildup on the pin or contaminant, and it's prohibiting that valve from being able to open to feed more. Or it could be just a high superheat adjustment, but again, we don't want to adjust that stem until we've kind of canceled out any other variable. I won't read every one of these, but just know that on that PT chart has these. So high suction pressure, low superheat. In this instance, you could have just an oversized valve where it's not able to restrict down to enough to kind of choke that flow. You could have, again, contaminants. Here, now you have something that's restricting that valve from being able to close. You could have a contaminant that's keeping that pin off of that seat, where you're not going to get a good superheat because you're sending liquid back to your compressor potentially. So you're feeding too much. And then here we got low suction pressure, low superheat. Now you're potentially hunting, and again, you want to take a look at all of the causes. You could have poor air distribution, which I'll talk about the distributor here in a second, but you want to evaluate all of these causes, because if it's not feeding properly, you're either starving the coil, you're flooding the compressor, or you're doing a little bit of both. So our distributor, the way they work, so here you see you have liquid refrigerant coming into the expansion valve, going through that tiny port that's going to create a huge pressure drop, and it's going to change it to two-phase flow. So you got liquid and vapor mix, right? So to feed all these circuits, they need to be identical. They need to be the same diameter and same length, because liquid's going to take the path of least resistance, right? So what we want to do is we want to make them all equivalent, but for that two-phase flow, for us to properly distribute, we need to have this nozzle in here, and it's sized based off of how many circuits and system capacity. So there's a few different variables. Make sure we got the right nozzle in there. That nozzle is going to create an extra pressure drop to make sure that we're feeding two phases in each circuit. Otherwise, if it's not sized properly, if it's too big, you'll have all gas going up here, all liquid go down here, and then you'll have not an even ice pattern on your evap coil, and you know you got something going on, or it could be a plugged circuit. So one way to know if you got a plugged circuit, make sure on the return circuits, make sure that each circuit's running around 3 to 5 degrees within one another. Anything larger than 5, you got something going on there. So just make sure that you do have the proper nozzle selected. Also, to check a plugged circuit, you can't just pressure test the evap coil. You're gonna have to check each circuit individually. So, any questions so far? We're good? So our sight glass, the see-all, it's unidirectional. You put it in either way. All it's doing is it's taking a sample of that refrigerant, and that little green dot's a little filament that if moisture is present in that refrigerant, then it'll start to turn, I think it was chartreuse, ballpark mustard, and eventually yellow. So if it's really yellow, it's your system's chock full of moisture, and you got to change out your catch-all so we can pull that moisture out of the system. This is just showing you different ppm, I think, on different refrigerants. I honestly don't memorize this. Basically, as it starts to turn brownish to yellow, just know you have moisture present, and you got
I've always found you gotta soak it wet for that thing to change color.
well, and the whole thing is, if it's soaking wet, we want to get all that out of there, right? So
It's dead before you, yeah. The compressor is already shot.
Right.
Before that changes.
Well, in some cases not though.
No.
I've seen cases where it's yellow. Here's a trivia question for you. What happens if it's black?
Oh.
It means you burn it up installing it. You need to put a new one in. But we do have a kit, just a filament kit, where you can actually replace that.
Really?
A lot of guys will just get a new see-all. They're not overly expensive, and it's kind of on the back side of it, you have to pull the nut off, and it's almost easier just to buy a new see-all. But just know, if moisture's present, we want to pull it out, because moisture can form as an ice in your expansion valve and plug the valve. Or if you're running high superheat, you get to a certain temp, I think in the later slide, you can start to decompose refrigerants that will interact with the water and create acids. So we want to keep the system dry. Our see-all, we recommend just on the outlet of liquid line before the expansion valve, just to see if there's any moisture present. We do sell a CSG catch-all sight glass combo. So in some instances, you might not have the room to actually put a sight glass. We do have a CSG where the sight glass is just mounted right on the catch-all, all one piece. The only problem is with that, when you gotta replace your catch-all, you gotta replace the whole thing. So, which is not a problem. We'll sell you another one. But with our catch-all, just look that there's what do we got? For R32 and 454B, you're getting very low pressure drop across those valves because the flow rate is less. So if you think about it, the flow rate's less, so it's that refrigerant doesn't have to flow through as frequent as a 410A charge to do the same amount of refrigeration. So with essentially less of a current, you're going to have less of a pressure drop going across that valve. So you just want to make sure you're sizing it based off capacity and based off the refrigerant. Again, leverage our virtual engineer program for that. And then talking about the catch-all, we have a solid core construction. It's made up of activated alumina and molecular sieve. So the activated alumina will neutralize acids. Molecular sieve will trap moisture. So if anyone's ever cut open a cheap filter dryer, it'll just have like a bunch of bead desiccant and a fiberglass pad, and it's just packed in there. Well, that construction, all it is filtering basically at the top, and it's going through that system, but it can easily plug. Our solid core construction, basically what happens is refrigerant will come in and it'll encapsulate this whole thing, and then it'll pull through all around. So you have more cubic inch filtration, and it's a solid core. So with the granular desiccants, what will happen is current friction will have them rubbing up against one another. Those beads will tend to break down. You can get by that fiberglass padding, and sure enough, it'll get caught like right at the port of the TEV. Whereas this is a solid core. Basically these cores are baked and they're solid. They almost feel like a sand. But then we also have there's a wire mesh, and then there's a polyester pad there the polyester pad will filter down to, I think it's like 20 microns. And if I'm not mistaken, red blood cells like 10 microns. So you get really good filtration with these. But they're used to remove acids, any kind of solid contaminant, trap moisture as well. Talking about compressor, so if you're getting north of I think it's 275, you can start to see either lubricating oil or refrigerant start to break down. Actually, I think next slide says it. Basically, general rule of thumb is if you're measuring 200 degrees, 6 inches down on the outlet of the compressor, at about 75 degrees, that's going to give you the actual temperature of the compressor inside. 275 is about or 300 is about the limit of where you want to be. Anything hotter than that, you're going to start to see breakdown. If you're using our brazeless refrigerant fittings, Zoom Lock Max, we have a max operating pressure or temperature of 250 degrees, because anything north of that, those O-rings can be compromised. So here you see at basically 300 degrees or less, it's safe operation, but once you get to a little bit north of 300, you can see piston and ring wear on the compressors, and then mineral oil will decompose at 350, POE at 400, and then it's just going to wreak havoc, because that's when, if you're dealing with high superheats, you probably got moisture in the system somewhere, and it's going to just create acids. It's going to start attacking the coil windings, and then got to buy a new compressor. So just good rule of thumb. So to combat high compressor superheat or discharge temps, it all goes back to making sure that you have the right superheat setting in your TEV, because that suction line is going back, acting as a cooling agent, right? So we want to make sure that we're insulating that suction line, not losing some of that cooling agent to go back to the compressor. Make sure your condenser coil's clean, so that it can emit that temperature into the or that heat into the ambient. Also, you can install a compressor, body cooling fan, or a cooling module. It's not really my expertise, but it's another recommendation for you. Just make sure that your superheat is at the appropriate setting, because it will just raise temperatures all throughout the system. Plus, you're not going to get the desired cooling you want at the evaporator. So, again, a little bit more on this compressor overheating. You're going to create acids as the oil and refrigerants break down, and then it's going to essentially just attack your coil windings. And a compressor is the most expensive component in the system, right? So we want to do everything we can to make sure that we're protecting that. Here's showing you a coil windings where the copper's exposed, that the insulation is broken down from the acid. And if you think acid's present, we sell a TA1 acid test kit. Has anyone used one of these before?
All the time.
Yeah, so pretty self-explanatory. You want to just take an oil sample from your compressor, and then depending on if it's POE or mineral oil, select the right vial, dump it into your oil sample. If it comes out purple or red, we're not showing any kind of acid present. If it gets to orange or yellow, there's a chemical reaction with these vials that will react with any acid that's in the oil. Basically, it's showing you, let's A, change your catch-all out so we can neutralize any acids, but B, let's figure out what's going on. Why are we running these high discharge temps where we're breaking this oil and
How do you
refrigerant
get the
down?
oil out of the compressor to test it?
How do I? There usually, isn't there a spot on the compressor where you can get an oil sample?
Not really.
Not hermetic.
Yeah, I was gonna say semi-hermetics, you have it, but not hermetic compressors.
Not hermetic.
Well, you get an oil sample maybe, I mean,
You
depending
gotta
on the
take it out,
system.
throw it upside down. That's what you
Yeah,
gotta do.
If you're
Yeah.
gonna do that, you may as well change it.
You might as well change it, yeah.
right. Well, don't do that without buying one of our TA1 acid test kits first. Daddy's gotta eat, all right?
Yeah.
I'm honestly, I'm not exactly sure how you would pull an oil sample,
That's the problem.
but it depending on the system, if you have an oil reservoir or something where you can get access to it.
Usually you don't, so they have those ones that test vapor,
Okay,
and they work very well.
do that?
Yeah.
Okay. That I don't know. That's a good question. I
Chemical.
will find that out
Those
though. 'Cause I'm-
total test kits?
Yeah, yeah,
I smell chlorine before those things.
yeah. Yeah, you're probably right.
All right, so we have our standard core. Let's say it's the 4864 or used to be 4864. Basically, our standard core. I don't know the exact percentage makeup, but let's just say we like their blue label cans. They they say high acid. I don't know the percent molecular sieve or activated alumina, but they say high acid. Let's just say it's a 50-50 blend. So you got 50% of that core is attacking any acids in the system, right? Well, then you see, if you're familiar, we got the RCW 48s, gold labels. There's more molecular sieve and less activated alumina because those are specifically attacking high moisture, right? Well, then we have these green label, which are our HH cores. So years ago, Hussman came to us and said, hey, during compressor burnouts, we're seeing a lot of wax in our system and we want to get that wax out of the system. Let's develop a filter or a core that can attack that wax, right? So we came up with the HH core. What we did was we introduced activated carbon, which is the black spec in these. But to do that, we had to take away a little molecular sieve, a little activated alumina, because it's a finite space, right? But these will help, and we recommend doing these for any refrigerant retrofits or compressor burnout cleanups. It's gonna help pull those waxes out, right?
If the oil came from Pennsylvania, it's more wax. If it comes from Texas, it's less wax. So it depends on where the oil came from.
These all come from St. Louis, or
Well, but
Washington,
I mean,
Missouri.
Originally, when the oil came out of the ground.
Oh, you said well, yeah. As far as we're concerned, when the wax or the oil breaks down, it's all wax. So, or at least Hussman was dealing with it. That's good to know. I didn't know. It's all mineral oil,
Wax
right?
on, wax off.
Yeah, lot of wax in the system. So we have these HH cores, and the product manager, his last name I believe was Herman, and Hussman co-developed these. I think that's where they get the HH was Herman Hussman. I always think high heat compressor burnout. Use the HH core, clean up the system, and then go back to the RCA 48s. But we do have it, the replaceable core and as well the sealed model catch-all. If you are using in the suction filter side during a compressor burnout cleanup, you can use these HH cores in the replaceable shell suction filter as well. It's a temporary installation because as you see, you are going to get additional pressure drop because even though it's porous, it's a solid core and not a pleated filter. But it's going to help neutralize acids, pull out any particulates in the system. But just make sure that you're using this 6171-5 screen. It's a bit more fine mesh in case you have that core, since it is like granular sand. You don't want any of those chunks going back to the compressor. So want to make sure that you're using that additional screen. All right, so here just showing you're checking for acid at the compressor, right? So we're gonna replace the filter dryer and the oil filter. You got the oil level control. There might be on a rack system. There might be a
You should have
access port there.
You
where
should
can
have a
get-
crankcase valve on those compressors anyway.
Okay, so you're gonna be able to pull
Yeah.
oil from that. But then on our replaceable shell catch-all, we also have this secondary filter. Basically, so if you ever seen one of our replaceable shells, you got that screen mesh, right, that goes up into the hole in the replaceable cores. We have this secondary filter will slide over that. That's that same fiberglass padding that's on our sealed catch-all, and that will get you down to the 20 microns. The cores themselves, I think, will filter down to 40 microns and like 60% efficiency. But the secondary filter will get you down to the 20 at a higher efficiency. So, anyone do a restaurant work or whatever, we also have a cap tube filter dryer. Here's a picture, you probably can't see it, but basically a cap tube system, the waxes build up and can plug those things really easily. So rather than having to pull out a whole new cap tube system, we do have our CO52 cap TTHH that uses that HH core that will attack those waxes and keep that cap tube clean for you. So basically, here's the conditions that we want to focus on when it's time to replace your filter dryer. So during the initial system installation, right, we're going to put a new filter dryer in. And anytime you open that system up for any service, anytime you open that system up, you could be introducing a contaminant. Either it could be dirt or it could be humidity from the air, right? So we want to make sure that we're putting in a new catch-all. If you got a 5-pound pressure drop going across that catch-all, just means it's chock full. You can't pull out any more contaminants, so you want to replace it. If you're using a sight glass and it's starting to show moisture present, change the catch-all so you can pull out more of that moisture. And then if you're using an acid test kit and it's showing acid present, change it out as well. During a compressor burnout, we recommend sizing one size up. Temporarily, it's just giving you additional cubic inches of filtration. And then during a major compressor burnout cleanup, put in a core on the suction filter side. That's going to help also attack those contaminants. And then once the burnout's complete, then you can go back to just the normal size for good preventive maintenance. So, talking about solenoid valves, as I mentioned earlier, our HP solenoids were the only ones that we tested with UL to get the A2L ratings for. So if you're using an A2L system, you need to put in a liquid line solenoid. Just make sure you're buying the HP version. HP version, it was just a slight modification to our normal liquid line solenoid to combat the higher pressures HP of like 410A. Basically, there was an additional kickoff spring that we needed to get in there to be able to close that seat disc. So, as you can see, some capacity differences. You want to make sure that you're sizing it properly based off of the refrigerant you're using, and then just use our virtual engineer program to help size these. You always, all right, next slide. Don't ever size your solenoid valve on connection sizes. I was talking with Tom about this earlier. This is one of the things that people do all the time, say I need a 5/8 inch solenoid valve. Well, 5/8, specifically 5/8 connections, we have 4 different size solenoid valves that have 5/8 connections. So right off the bat, you're batting 250 at best to make sure that you're properly sized. If it's undersized, you're starving the coil. If it's oversized, you're not getting that required pressure drop to keep that seat disc down, and you'll get a little bit of seat leakage when you end up flooding the system. Yeah, so you want to make sure you're sizing it based off of capacity and not line size. We have 2 different construction, basically designs of our solenoid valve. We have a direct acting where the plunger actually is directly acting on the port, right? And then we have the pilot operated where as the coil is energized, it pulls the plunger up. This pilot port will open, allowing refrigerant to flow, what creates the pressure drop where this whole seat will raise, opening up the port. The reason why we don't have all direct acting is the larger ports, we would need a coil like this big to create a big enough of a magnetic field to pull that out for the pressure. So we do the pilot operated type. On the pilot operated, we do need at least a 1 pound pressure drop across that valve That way, when the coil's de-energized, it blocks that pilot port, this whole seat disc comes down, and then refrigerant will stack on top of that to keep that closed. But to keep it closed, we need at least 1 pound. If there's no pressure drop, that thing will tend to float a little bit and you'll get refrigerant going through that valve even when it's de-energized. So, as you can see here, E3, it's direct acting. We don't need a 1 pound pressure drop. We say general rule of thumb, always institute at least a 1 pound pressure drop, but there are instances, like for example, this E3, for a 1 ton system, you're only gonna have 0.9 pounds of pressure drop across an E3. But you need, for this E6, you need a minute, the smallest size we could do would be a 2.9 pound pressure drop. So you wanna make sure that you are sizing them properly. Again, use virtual engineer, rely on us to properly size these for you. All right, this is a very busy slide. I'm not gonna read this. I'm not expecting you guys to read it. Basically, I just wanna say, if you guys have ever walked down a freezer section and you hear humming, it could be the liquid line solenoid valves on top of the cases, and it could just be a foreign material in that valve stem that's creating a vibration, or could just be something as simple as the screw on top of the coil is not tight and that little tab just could be fluttering. But basically, typical malfunctions, coil burnouts are very rare, but it most likely could be improper electrical characteristics on these. So you just want to make sure, if you do have a valve that you think has failed, especially if it's under warranty, cut it out and bring it to your wholesaler. We can evaluate it. We can send it back to our quality lab to take a look at it, make sure it's functioning properly, or if there is a defect found. So I won't get into too much of that. EEV updates. Our electric expansion valves, they're dumb valves, right? They're only going to control what the controller's telling it to control. So all the refrigerants and everything are going to be loaded into our different control options that we have. Just know that, as with TEVs, electric expansion valves, you're going to see higher capacities both with 454B and R32. As you can see, R32, we can be 55 to 60% higher capacity. So I think our RSEH valve, we can size an R32 electric expansion valve up to 600 plus tons. So there is a significant range. I mean, look, for 410A, it's $399. Now granted, when you're getting those higher systems, there's gonna be a wider range, but there is a significant increase in capacity from the A2Ls, or to the A2Ls from 410A. Electric expansion valves, you're going to get a much better control with it. You can dial down, so a conventional port TEV, I said 25% capacity. You can dial down to about 10% capacity on an electric expansion valve, all the way up to fully open. You got a wider range. You can pull down a system much quicker than a TEV, and then you can have a very tight superheat window where you're having a smaller range of modulation with your superheat setting. A lot of equipment's going to EEVs because it's a more precise control. They're not cheaper though. There's more things to consider with an electric expansion valve, right? So now you have to worry about temp sensors, pressure transducers that are going to act as like your evaporator pressure and your bulb. You need a controller, something to tell it what to do, whether you're tying it into a standalone controller or maybe a system controller. So there's a lot of different things to take into consideration, but they are going to give you a much more accurate control. Plus, with electric expansion valves, the controllers, we have a lot of different options where you can get remote access. You can use a Bluetooth capability with your phone to diagnose things. So there are a lot of advantages to them. So that's on the HVAC side. I want to take a look here a little bit on the refrigeration side. So you have the new A2L refrigerants for refrigeration. As mentioned at the beginning of the training, two different GWP requirements. So if the charge is under 200 pounds, the GWP has to be below 300. So 454A satisfies that with a 239 GWP. It is a blend R32 and R1234YF. But if the charge is over 200 pounds, now the requirement drops to a 150 GWP, where we have two different options, basically 454C and 455A. They both are just under the 150, right? One thing to note, our 455A, the blend, it's also blend with CO2. So because of that, there's like a 20-degree glide on that.
So they don't have 454B?
No, 454B is an air conditioning application or
Oh, okay.
refrigerant. So these are for refrigeration. But just note with, I think actually, next slide, yeah. So 454A, we had to create a TC/TZ charge for that. But 454C, 455A, we're using the R22 charge. So the PT characteristics are close enough to where we can use that. So of all the new A2L refrigerants, we only had to create 2 new charges, which is good, but there's still some sizing issues that we're going to make sure that we're selecting the right refrigerant, the right application. Our 22, so 454A and 454C, you're showing a capacity drop compared to R22, but you can still use that. You can still use that charge. It's saying 454A and 448 are very similar, like pressure temperature characteristics. So on your PT chart, you can use the 448. We do have the KT47. Essentially, the KT, are you guys familiar? We got a KT43 and a KT45 power head. KT43, the power head assembly, basically it's all about the hex head, how it screws onto the TV. It's a 1-inch diameter. KT45 was 1.25 inches. We went to a new design, which I think is on this slide later. Basically, we're doing an automatic induction braze, the cap tube right to the top of the element. The reason being, it was the highest turnover position in our factory. You'd have like 4 guys standing around this rotating table, one guy putting together the element, one guy brazing that button on, another guy doing something else, another guy brazing the cap tube in. So we were continually having to train new people to do that construction. You had guys that were either cooking the valves or not giving uniform braze joints, burning themselves, and so we would just see a backlog of elements, and we're like, guys, our bread and butter, like our TEVs, like these shouldn't be long to make. And so Parker, I think their idea is to get a torch out of everyone's hand in the factory. So let's automate the process so that we can make them more uniform, have less room for error. So, so what we did was we made a KT47 and eliminated half the SKUs of 43s and 45s. So it was kind of a efficiency mechanism, but we have a KT47 wrench now that it's 1 1/8 inches. So, so when you hear KT47, that's the new design. Just went into effect end of last year, beginning of this year. So, one thing to note that our on refrigeration systems, you cannot retrofit an A1 system to an A2L. So you're gonna have to have all new equipment for that. So, per the UL 60335-2-89, the A2L systems require the use of 2 safety shutoff devices to prevent mildly flammable refrigerant leaks. So basically, on say a walk-in box, what you're gonna have, we have our SSOV. It's essentially we took our liquid line solenoid and it was a small engineering change where we actually put in a spring so we don't require the 1 pound pressure drop. There's a spring that when that coil's de-energized, that seat disc will shut, and then there's a spring that'll keep it shut. And it's basically, so you'll install the liquid line solenoid just on the outside of the box on the liquid line. And then we have our CSOV check valve that you'll install on the suction line just on the outside of the box that satisfies the two safety shut-off devices. So basically your SSOV will be tied to a leak sensor in the box. Senses a leak, it'll deactivate or de-energize the coil and that will shut off then. So they're gonna require it. There's a lot of equipment manufacturers that I think that are probably considering adding 2 features in their design. Just know that these are an option and they're available today. So, all right, here just a little bit more, showing you for the SSOV, we have 1/4 inch up to 1 1/8 inch. For the check valves, we have 5/8 up to 2 5/8. One thing to note on the check valve, there's a rubber O-ring in there, so make sure you're keeping a torch away from the body of that. You can melt that O-ring easy. So that will satisfy the SSOV here. Oh yeah, I'm showing you. Basically showing the SSOV right on the liquid line and then the CSOV. I'll be honest, these are mildly flammable refrigerants. I'm not so afraid about these. When you get into CO2, it's much more critical because if you're in a walk-in box and that thing's full of CO2, a technician can suffocate like that with the absence of oxygen. It can get real dangerous. So I think these are good best practices. And I think something along this line will probably be in the design for CO2 systems, which I'm talking about basically real quick here. So we do have a line of CO2 products. I'm not gonna get too far into CO2 because I'm still learning this quite a bit as well. But just know we have a CO2 innovations catalog that basically shows the product rating or products that we do offer. So we have a gas cooler valve, flash gas bypass valve that deal with the transcritical side of CO2. When transcritical, basically, it's not a liquid state, it's not a gas state, they basically call it like a plasma, which is really kind of, if you look at like a, yes.
CO2, we used to use liquid CO2, dry ice, to freeze roof sections because you have tar and then fabric, tar, fabric,
Yeah.
tar, fabric. We want to separate them, so they poured liquid nitrogen on them and then CO2. And so we used to get dry ice in paper containers.
Mm-hmm.
Well, one day the container that we stored it in, the guy couldn't get to it, the door was closed or something, so he left it out for 6 hours. So these cardboard, or these paper boxes, the entire dry ice, gone.
Yeah.
So you take these boxes, which used to be dry ice, go like this and it all collapsed into a bunch of paper.
Right.
So if you stuck your head down in the place where they stored it, oh, just the lightest whiff of, whoa! It's like,
Yeah, I mean, well, you're depriving yourself of oxygen at that point.
yeah.
Because it's all carbon dioxide, so
So
yeah.
even it wasn't, you were gonna die from oxygen, it's just like burned the nose.
Yeah.
Ammonia, same thing.
Yeah, I definitely don't like
NH3.
the smell of ammonia. that's not
Yeah.
safe. Yeah, but well, in these systems too, I was at a natural refrigerant symposium a month ago, and they were talking about how because of the pressure, the
Much
pressures are.
Much higher.
Yeah, so our new components that we have rated, it's 1300 PSI, I think it's like 90 bar, right? But you're dealing with the filter dryers collecting dry ice depending on what's happening in the system. So it's a whole new ball game. Like if it's subcritical and you're below certain degree, then it's just acting like a normal refrigeration cycle. But once you get above a certain temperature, now, and the efficiency of these systems actually goes down, but nobody is looking at the energy usage, everybody's looking at the GWP requirements.
Oh, yeah.
Because CO2 has a GWP of 1, right?
Yeah.
So it's not hurting the environment any,
Yeah,
but you have I think it's 87 degrees, you get north of 87 degrees, now it's in transcritical mode. Now, the refrigerant cannot be held in the pipe, because if the temperature swings, like, you could have massive expansion where the pressures just skyrocket. So the compressors are having to run full time, and you're bypassing gas in the system because the CO2 can't just sit. Like, you can't be in a pump down mode or whatever.
Yeah.
So it's real interesting, but we do have a lot of components. So we have our electric expansion valve, a pulse width modulating valve, which essentially acts kind of like your expansion device feeding the evaporator. We do have a 90 bar sealed catch-all right now. The only ones, I think it's a CO83, but we're in the process of, I think next month, we're gonna be releasing a replaceable shell 90 bar rated catch-all. Our ball valves, it's a EBV PR ball valve. Essentially what they're a ball valve with integrated pressure relief. So if there was ever an instance where the system stopped, as that pressure builds up, the bottom of that ball valve has that pressure relief. They'll be able to burp that higher pressure off. And then we have a 90 bar oil filter as well that are set up. Main components new though, we have the gas cooler valve and the flash gas bypass, but again, I'm still learning this, so I'm not in a position right now where I can really talk too much in depth on the system. Here's the ball valves I was telling you. So you have, the old method was you would have to pipe in a check valve in parallel, right, to help some of that, relieve some of that pressure. But this new EBV PR basically has pressure relief built in, integrated. So there's a lot of systems that are using these. Up to, we have 3/8 up to 1 1/8. We are actually currently working on 1 3, 1 5, and 2 1/8 inch size, larger sizes. One of my OEMs is actually looking to use them. They're going to be using them for the A2L refrigerants, but well, we're in the process of rating these for the higher pressures for CO2. Here, I was mentioning the filter dryer 90 bars. It's essentially, it's all the same makeup of molecular sieve activated alumina, but it's just a beefed up body that's able to withstand those pressures. And then also the oil filter, same instance. The pulse width modulating I was talking about a little bit ago. There's 8 different sizes depending on what you're looking to do. That is essentially just a glorified solenoid valve, but it's acting as your, not your expansion, but your feeding device into your evaporator coil. For propane, real quick, just a couple more slides and I'll let you guys wake up. But propane R290, it's been around for a while. We do have a replacement valves available. It's gonna have a red tag on it, and then it's gonna be showing that it's flammable ATEX, or is it the ATEX compliance or whatever. We do have a few different size valves. As you see down here, there's an OEM that we can go up to a 12-ton system. I don't know of any propane systems that are that large, but I do know in Europe they have higher, like I think we were like 6 grams or something here in the U.S.
Something ridiculous.
Something really small, but
All
they
these-
have like
They're way
3.
ahead, they're way ahead of us.
Yeah,
on-
they-
I think there's
they're-
3 transitions.
Yeah,
Aldi's has R290.
all their
in
coffin cases.
in the
Yeah.
freezers,
Yeah.
Yeah, but and they're all remote condensing units, right? They're not tied to
Yeah.
any rack because all of their medium and low temps all CO2. Or if it's not, it'll be all new Aldi's are CO2 on their rack, and then all the coffin cases are 290. Yeah.
Interestingly enough, propane and butane are the most efficient refrigerants ever, and they've known that for decades.
Oh, it's very
Yeah.
efficient.
They have that downside though.
Yeah.
It's only a small amount of charge
Yeah.
in, this, you know.
Yeah, because of it's an A3
Efficient.
flammable rating, so they
Yeah,
don't,
you
they don't
move a lot
want
of
somebody
heat.
blowing up a whole
You can move a
building.
lot of heat with a little
Yeah.
charge.
But I mean, yeah, our refrigerators in our house been using R290 for years, right?
Yep.
So,
Yeah.
ammonia is a very efficient as well, but it's
565.
very corrosive as well, right? So,
Oh, it does a number on copper.
yeah,
So some smart aleck at, SK Wellman, the maintenance director was trying to teach this guy a lesson. So I says, hey, the guy's taking out black iron pipe for the ammonia and putting in copper. He says, shut up, don't say anything. This guy thinks he knows everything. 2 weeks later, leaking. He had to go back and change them all. It's trying to teach him a lesson.
yeah, I think you taught somebody a lesson, probably.
You're just the
Probably
supervisor,
the
you don't know anything.
Contractor probably loved him too because
tell me
of how
what
much
to
money
do.
out of the pocket. Well, just know we do have, the designation is O. So, for R290, so we do have a EROE valve available, that all these BBI valves, BBI basically it's a balance port construction. Those are OEM, part numbers, but, we do have an ERO valve for R290. We have an ER, an R, and an SR. For 290, there's no pressure taps, per the requirement. We can't have any pressure taps on our catch-all, so it's a sealed catch-all. Very small, the CO32, it's, because they're small systems, right? They just need a small catch-all for it, but, our catch-alls are rated for, R290. And then here's what I was talking about earlier, I did have this in there. But basically, here's what I was talking about, this little button on top, where that eliminated one braze joint by going to this construction. Now we're just brazing right to the top. It's essentially the same exact function, it's just a little bit different engineering design for us, so. And then here I was mentioning the KT47 wrench. So Virtual Engineer, which I talked about so much, it's on our website. Here's a QR code if you guys ever wanna like pull it up. If you just go to sporlan.com, you scroll down a little bit, and on the right, you'll see Virtual Engineer, like not even halfway down the page. This is going to basically show you. So basically, you pull on our website, it's right here, right? And then once you pull up onto it, if you've never been on it before, it'll basically ask you a consent form like you're using it. Go ahead and consent. If you want to sign up for our mailings or whatever, we're not going to spam you. It'll be like maybe a once a month email that sends you any updates. But on here, there's a small YouTube video as well as a climate control blog, basically showing you how to use the program. It's very user friendly. Jason Forshe's applications engineer who manages the program. I will say, if you ever get on there and you're tinkering around or you're trying to size something and you're like, what the hell? Like, it's telling me some crazy valve that I know is not right. Send me a note, take a screen print of it, send me a note. I can double check the work. If there's been 2 instances since I've been here that the program wasn't working right, and I just had to send Jason an email saying, hey, what? I think it was like it wasn't giving me a solenoid valve that I knew would work for that system capacity, and it wasn't pulling it up as an option. So I sent him an email, and so all the kinks for the most part have been taken care of. But if you run into something, let me know. And then also, just to the left of our website is our Sportland literature. That's basically just an electronic version of our wholesale manual and additional forms and supplemental bulletins. So all of our bulletins are available online. If you go to a wholesaler, they might have the old Sportland blue binder.
403, yeah.
Yeah, but not all of our print material has been updated. Like, there's some bulletins that like RSC might have. It's like 2011 was the last print. Here we are, 2025.
Oh, yeah.
Electronically, they're all updated.
Yeah.
So, and we're going through right now trying to figure out, all right, we need to update certain bulletins so we can circulate those in print. That's an
Yeah.
initiative we're going through this year right now,
Have
so.
AI do it for you,
What's that?
artificial intelligence.
Yeah, well, I'm sure we might be, using that if it's available, so.
Coming up, yeah.
Right here, so when you go down, you'll see this virtual engineer on the right side, just to the left of it is the HVACR training and learning. Or no, this is not our literature, this would be our chill skills, so we have like 33 pre-recorded webinars. I think it's more than 33 now. But it could be something as like how to calculate superheat, could be a 10-minute video, up to like supermarket racks of the future. A lot of different components that we've had online webinars about. So and they're all free, available to watch. We got all the major social media. Follow us on everything. And then I think we have a Chili News right here. Chili News. This is going to be our newsletter that we send out once a month usually. That's going to have any updates that we have, any upcoming webinars that we're going to be hosting, any invitations at like AHR, visit us at booth, yada yada, whatever. That's basically how we'll keep you guys up to snuff on anything. And then with that, that's it. But again, here's my contact information. I know I kind of breezed through some of that stuff. I don't want to bore you to death on everything, but is there any questions on anything I covered or didn't cover?
You may have brought this up on your Zoom lock thing that you did last time, but do they cover A2Ls as well?
Yes, yeah. So our ZoomLock Max, ZoomLock Push are both A2L compliant for 454B.
So it's the max though, the line, or is that all of them? Is there two different kinds?
Well, we have a ZoomLock Max and a ZoomLock Push. The
Okay.
Push are like the tiger or the shark bite
Yeah.
construction. They're both A2L compliant.
Okay, so
And
even
actually,
the
they're
old ones that you-
R290 compliant as well.
Okay, the old ones though that you've been pushing out, do they still cover for A2Ls?
The old ones, like the RLS fittings now,
Yeah.
that
I think they do.
I
I'm
think
pretty
they
sure.
do, but
Yeah.
we don't work with RLS anymore. There was a separation, so we've gone to ZoomLock Max.
Okay.
So, but for RLS, I would check their website. My guess would be
I'm pretty sure they do.
because it's, I mean, it's, if I'm not mistaken, their O-rings are HNBR, same
Okay.
as ours, and the only main difference is they're soft copper, we're hard copper, and we're more compact.
Gotcha.
But are you using RLS right now?
Yeah.
I was gonna say, I would check their website, but I would think that they're A2L compliant.
Okay.
So, I can try and find out. But yeah, I think they are.
All right. Gotcha. Thank you.
Yep. Any other questions?
Thank you, Shawn.
You're welcome.
Yeah, that's great.